By 1941, America's railroads faced gridlock and crisis. Mile-long freight trains stalled on mountain grades, demanding a machine that defied limits. That's why the big boy emerged. 135,000 pounds of tractive force, capable of hauling 4,000 tons through hellish heat and relentless pressure. But raw power came at a human price, and the dangers inside its cab were far more real and personal than most realize. How lethal did this giant truly become? Otto Jabelmann paced the Union Pacific Design Office, pencil in hand, tracing the outline of a locomotive that had never existed before. Wartime demand had pushed the Wasatch route to its breaking point. Freight trains, some over a mile long, stalled daily on the 1.14% grades between Ogden and Green River. Double-heading smaller engines only clogged the tracks further, wasting time and manpower. The solution had to be radical: a single machine capable of dragging 4,000 tons up the mountain, unaided, without stalling or slipping. On paper, the requirements were staggering. The locomotive would need a tractive effort of 135,375 pounds, enough to haul a small town on rails. Jabelmann's team, working with A.H. Fetters at Alco, settled on a 488 four-wheel arrangement, spreading the immense weight over 1.2 million pounds when loaded across the rails to prevent track damage. 68-inch drivers balanced speed and grip, while a 150-square-foot grate area and 300 pounds per square inch boiler pressure promised relentless steam. Every detail was a negotiation between brute force and the limits of steel. Articulated frames allowed the engine to snake around curves, but introduced new points of mechanical stress. Bearings, rods, and the firebox would all be pushed to their limits. In the foundries, steel was forged and hammered, each rivet and wheel shaped to withstand the punishment of near-continuous operation. The big boy was born from necessity, but its very design hinted at the maintenance burden and mechanical risks that would shadow its service from the start. Inside the cab, the big boy's power came at a price measured in sweat and stamina. Temperatures routinely soared above 120 degrees Fahrenheit, even in winter, as the firebox devoured up to 15 tons of coal every hour. The engineer, the fireman, and the brakeman worked shoulder to shoulder in a space filled with deafening noise and constant vibration. Gauges trembled on their mounts, needles quivering as steam pressure pushed the limits. Every climb up the Wasatch meant hours spent shoveling coal, wiping soot from burning eyes, and fighting to stay alert as the locomotive thundered forward. Oral histories recall shirts soaked through within minutes, boots sticking to the scalding deck plates, and the air so thick with ash that breathing felt like swallowing sand. The fireman's arms ached from feeding the stoker, while the engineer's hands never left the throttle or the brake. Brakemen watched for signals and hazards, eyes stinging from cinders, nerves stretched thin by the knowledge that a single missed alarm could spell disaster. Mechanical stress was everywhere. Pipes rattled, bearings groaned, and warning lights flickered as the miles rolled by. Crew logs tell of near misses, a flashback in the firebox that sent a sheet of flame across the cab, a brake shoe failure on a steep descent, a hot box that nearly ignited before the next sighting. Each incident left men shaken but determined, pushing on because the schedule demanded it. Fatigue set in long before the end of a shift, blurring judgment and slowing reflexes. In these conditions, the line between routine hardship and true danger was razor thin. Big Boy. 4005 thundered east across the Wyoming prairie, hauling 62 freight cars and a caboose, its speed holding steady at 50 miles per hour. In the cab, engineer Leo Murray watched the track ahead. Fireman Lawrence Indries kept the boiler fed, and front brakeman James Anderton monitored signals through the haze of coal smoke. As the train neared Red Desert Siding, section foreman Kenneth Mayfield assigned the east end switch to Ralph Vicente, a new hire with little English and minimal training. The section gang worked nearby, their tools clattering against the rails. Suddenly, Anderton spotted movement at the switch stand. The points shifted, opening the siding just as Big Boy 4005 approached at full speed. He and Andres shouted a warning. Murray lunged for the emergency brake, slamming it into the slot. The locomotive surged forward, then pitched violently as its wheels struck the open switch. In an instant, 4005 tipped onto its side. The cab crushed beneath the tender. 18 cars piled up behind, steel and timber tearing across the prairie. Steam filled the air, scalding hot and blinding as Anderton crawled free, badly burned. Rescue crews arrived after the rear crew raised the alarm, but for Murray and Indris, it was already too late. Investigators from the Interstate Commerce Commission arrived at the wreck site before noon, boots sinking into scorched earth still littered with twisted metal. Their first task was to reconstruct the chain of events that led Big Boy 4005 off the rails. Inspecting the locomotive's running gear, they found no evidence of bearing seizure or mechanical failure. Grease patterns were intact, and the journals showed no signs of overheating. The rods and wheels, though battered by the derailment, bore only the scars of the crash itself. Attention shifted to the switch at the east end of Red Desert Siding. Measurements confirmed it had been thrown open moments before the train's arrival. Survivor testimony and physical evidence matched. The points were misaligned, and the switch lamp faced the wrong direction. The coroner's inquest and Interstate Commerce Commission report both cited negligence in crew assignment. Section Foreman Kenneth Mayfield had placed Ralph Vicente, a new hire with limited English and scant training, in charge of the critical switch. Vicente, acting on unclear instructions, threw the switch as 4005 approached at full speed. 9 hours after the accident, rail traffic resumed, but the official findings left no doubt. The disaster was not the result of a hidden flaw in the Big Boy's design, but a consequence of human error and institutional shortcuts. The cost was measured in lives lost and trust shaken. It is a stark reminder that the greatest machines are only as safe as the systems that govern them. In the roundhouses of Cheyenne and Ogden, the end of each run brought a new wave of urgency. Teams of machinists and boilermakers swarmed over the Big Boys, their hands blackened with grease and coal dust. Shop logs from the 1950s detail the relentless schedule: bearings inspected for heat damage, side rods checked for cracks, firebox bricks replaced after every few thousand miles. Lubrication points stretched the length of the locomotive, each one a potential failure if overlooked. The Big Boy's articulated frame demanded constant vigilance. Misaligned joints or worn bushings could sideline an engine for days. Pressure to keep the fleet moving meant corners were sometimes cut. Records show skipped inspections and extended service intervals, especially during peak freight seasons. Disputes between union crews and management flared over rest breaks and overtime as both sides tried to balance safety with the demands of wartime logistics. Every hour a Big Boy sat idle in the shop was an hour lost to the schedule. By the mid-1950s, a new presence glided silently through the yards. Diesel locomotives, with their streamlined bodies and lower maintenance needs, began to replace steam. Shop costs for diesel locomotives ran a fraction of those for a Big Boy. By 1958, the last of the class had been retired, their fires cold and roundhouse doors closing behind them. The era of steam's dominance had ended, not with a bang, but with the quiet efficiency of a changing system. 8 Big Boys survive today, scattered across the country, silent relics of a vanished era. Most rest in museums or parks, their immense frames drawing visitors of all ages. Children stand dwarfed by wheels twice their height, while older guests recall the thunder of steam and steel from decades past. For years, these locomotives sat idle, their engines cold, paint peeling, metal slowly succumbing to time. In 2013, Union Pacific set out to do what many thought impossible. The goal was restoration of Big Boy 4014 to return it to working order. After more than 50 years on display in California, 4014 was moved to Cheyenne, where a team of restoration technicians began the painstaking process of bringing it back to life. Every bolt was loosened, every bearing checked, every pipe and valve tested or replaced. Modern safety standards guided their hands, but the spirit of the original design remained untouched. Restoration reports detail the obstacles: cracked steel, worn bushings, and the need to fabricate parts long out of production. In May 2019, 4014 steamed under its own power for the first time since 1961. Crowds gathered along the tracks, drawn by the rare sight of history reborn. The Big Boy, once a symbol of raw power and risk, now stands as a living monument to the skill and dedication of those who keep its story alive. Today, Big Boy 4014 thunders across the rails as a living relic, drawing crowds instead of cargo. Its revival is a reminder: every engineering marvel carries risk and responsibility. As we push technology further, we inherit the same challenge: balancing ambition with the human cost that never disappears.